So in this video, we're going to look at how we integrate with partial fractions. So if we look at this function here and this integral here, we have a denominator of x minus 1. Now when we integrate with factors such as this, we just have a constant on the numerator. But if we have a quadratic term that cannot easily be factorized, say for instance x squared plus 3, our numerator needs to involve an x term plus a constant term, and then we need to find the values of b and c. So this is what we're going to look at integrating in this video. Okay, so if we forget about the integral for a minute and just focus on this fraction, we can write this as a over x minus 1 plus bx plus c over x squared plus 3. And now we're going to multiply every term by this denominator. So we get 3x squared minus x plus 6 is equal to, this x minus 1 will cancel with this one, so we're left with a lots of x squared plus 3 plus, and I'll put this bit in brackets, bx plus c lots of x minus 1, because this one will cancel with this one. Okay, so now we need to find the values of a, b, and c. So the first thing we can do is let this bracket equal 0. So we'll say let x equal 1. So this becomes 3 minus 1 plus 6, which is 8. And that is equal to 1 squared plus 3, so 4a. So therefore, a is equal to 2. But now to work out b and c, we need to equate coefficients. If we look at this x squared term, the 3x squared can only be made by multiplying the a by the x squared, so ax squared, plus the bx times the x, so plus bx squared. We can divide through by x squared, therefore 3 will equal a plus b. And we know that a is equal to 2, so b will equal 1. And to find c, we can look at this constant term. This 6 can only be made from a times 3, so 3a, and then plus c times negative 1, so minus c. And therefore, we know that a is equal to 2, so 6 will equal 6 minus c, so c must equal 0. Okay, so now we've got our a, b, and c values. We can substitute these three values back into here. So we have 2 over x minus 1 plus b, which is 1, so just x, and c is 0, over x squared plus 3. So the integral of this will be exactly the same as the integral of our partial fractions. And now we can split up this integral. So this becomes the integral of 2 over x minus 1 dx plus the integral of x over x squared plus 3 with respect to x. We'll do this first integral in blue, and we can move a 2 in front of the integral sign. So we have 2 times the integral of 1 over x minus 1 with respect to x. And the integral of 1 over x minus 1 is the natural log. So we have 2 times the natural log of x minus 1 plus the constant term. And the second integral we'll do in green. So we have the integral of x multiplied by 1 over x squared plus 3 dx. And if you look at this, if we differentiate this denominator, we get this x term, or we get a scaled version of this x term. So because of this, we can use reverse chain rule. So if we let y equal the natural log of x squared plus 3, we can work out dy by dx, and this will be 1 over x squared plus 3. But now we need to multiply this by the derivative of x squared, so we multiply it by 2x. So if you look at our derivative and our integral, we need to scale this to cancel out this multiple of 2. So we'll multiply this by a half, which means we need to multiply y by a half. And this will give us our integral. So this will be equal to 1/2 times the natural log of x squared plus 3, plus the constant term. So we have our first term here, which is 2 times the natural log of x minus 1, plus this integral, which is this one here, plus 1/2 of a natural log of x squared plus 3, plus the constant term. So now we can use the rules of logs. We can move this 2 up to here using a power rule. So the natural log of x minus 1, actually I can make this in curved brackets because it will be positive, so x minus 1 squared, plus, and we can move this half to the power over here, so this becomes the natural log of the square root of x squared plus 3, plus the constant term. And then we can use the multiplication rule to put these two together, so we have a natural log of x minus 1 squared multiplied by x squared plus 3, plus the constant term. So this is our final integral. Okay, let's try one more question. Okay, so for example 2, we've been asked to integrate x minus 4 over the product of x plus 1 and x squared plus 4 with respect to x, and to show that this integral is equal to this. Do you want to try this question yourself? You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you had a go. So the first thing we need to do is we need to use partial fractions as being identical to a over x plus 1 plus, and because we have a quadratic factor which cannot be factorized, we'll say bx plus c over x squared plus 4. Now we'll multiply everything by this denominator, so we get x minus 4 is equal to a, and when you multiply this by this, the x plus 1s will cancel, so we've got a squared plus 4 plus bx plus c, and when we multiply this by all of this, the x squared plus 4 will cancel, so then we get x plus 1. So we can eliminate this term by letting x equal to -1, and then we get -5 is equal to -1 squared plus 4 becomes 5, so 5a, and this will cancel to make 0, so therefore a must equal -1. And to work out b and c, we need to equate the coefficients. So if we look at this x, this is made by multiplying bx by 1 and c by x. We can cancel out the x's, so 1 will equal b plus c. And we can use this -4, because that is made by multiplying the a by the 4, so 4a, and the c by the 1, so plus c. And we know that a is -1, so -4 will equal -4 plus c, so therefore c must equal 0. And if c equals 0, then b must equal 1. So now we have our values of a, b, and c, we can substitute these back into our partial fractions. And because I don't want to start with this negative here, I'm going to write this term first. So b is 1, c is 0. So we get 1 lot of x over x squared plus 4 minus, so this negative here, 1 over x plus 1. And because we've been asked to work out the integral, this integral here, I'm going to integrate all of this with respect to x. And like we did last time, I'm going to split this integral up. So we've got the integral of x over x squared plus 4 with respect to x, minus the integral of 1 over x plus 1 with respect to x. We'll evaluate this one in blue and this one in green. Okay, so like we did a few minutes ago, for this integral, we can use the reverse chain rule because the derivative of x squared is x. So all we need to do is scale it. So if we let y equal the natural log of x squared plus 4, dy by dx will be 1 over x squared plus 4 multiplied by the derivative of this inner function multiplied by 2x. So our integral will need to cancel out this 2, so we'll multiply it by 1/2. So the integral for our first function will be 1/2 times the natural log of x squared plus 4 plus a constant term c. And if we look at our second integral, well, this will be the natural log of x plus 1 plus c. So now we need to put these back together. We get 1/2 times the natural log of x squared plus 4 minus the natural log of x plus 1 plus a constant. We can use the power rule of logs and move this half over to here. So we get the natural log of the square root of x squared plus 4. And we can use the power rule here, so this negative becomes this negative up here, which is -1. So this becomes positive, the natural log of 1 over x plus 1 plus a constant term. So finally, we can use the multiplication rule of logs and put these two together. So we get the natural log of the square root of x squared plus 4 divided by x plus 1 plus the final constant term. Okay? Well, thank you very much for watching. I hope you found that useful. You can download the full lesson and worksheet from my website, mrmathematics.com. There's a link in the description below. Thanks again and take care.